To address the co-adaptation issue, which was causing our inability to make larger models as well as overfitting issues, Dropout was introduced somewhere in 2012. And since Dropout got introduced, it became quite popular. It helped researchers and practitioners build bigger models, achieve better accuracies, and since then until today, it is one of the most popular techniques people are using. So what is this dropout concept? What does it do primarily? In dropout, instead of learning all these weights together, we randomly drop some of the weights and learn the remaining. Here I've drawn out 3 iterations of model training, and if you recall the part when we went through the iteration levels in model training, we have these levels. We have an epoch, and under epoch we learn at batch level. This is the training iteration at a batch level, so I'll just write it down here. We are talking about the batch-wise iteration level during the training. So, without dropout, what happens is, during any such iteration level, training iteration level, we try to learn all of these weights together. And when we try to do that, co-adaptation happens, and it will naturally happen. But in dropout, it was a very interesting technique and very simple actually when you look at it. All we do is we'll randomly drop some of the connections, randomly, really arbitrarily. So let's say in this iteration level, I randomly dropped these 2 connections. In this, suppose I dropped these 2, and in this I dropped these 2. Now, when I'm randomly dropping these weights, these connections, they're not getting a chance to dominate anything else. Or, in other words, none of them are getting a chance to co-adapt because the presence of any other connection is not guaranteed. I'll repeat this part. Going back to this example, these connections were adapting to the fact that these strong weights are present there. But if these 2 connections do not have the guarantee that these weights will be always present, they do not get a chance to adapt. They cannot stay dormant at all. They have to work, they have to activate. So Dropout provides each of these connections a chance to perform, to contribute to the overall model inferencing or prediction. By the way, one important thing in Dropout, we fix the percentage of connections we are going to drop at every iteration. Here it is set as 0.5, which basically means 50% of the connections will be dropped at each iteration. So the weights are learned in this manner. In this iteration, we are going to learn, let me put it here, let me use another color. Here we are going to learn W1 and let me call it W4. Here we are going to learn W3 and W4. And here we are going to learn W2 and W3. In all iterations, we learn different set of weights, and the overall weight after finishing my all batch-wise iteration within an epoch, when my epoch ends, so let me write it down, at the end of an epoch, all these batch-wise estimates are aggregated and you take a mean of it, meaning at the end of the epoch, let me call this from iteration 1, from iteration 2, iteration 3. My final W1 will be equal to simply W1, W2 will be equal to W3, W3 will be equal to, because it came twice, and similarly W4 will be equal to so what we do here is you randomly drop, in this case, half of the connections at each iteration, and when your iterations finish in your epoch, finally all the estimates are aggregated together to give us the final estimate of each weights, which essentially is your learned model.